Okay, so my next topic is actually the core of my part, which is the chemicals. So we're going to be taking a look at types of chemicals, and the important thing that I'm going to stress on is actually on the chemical hazard, and later on we move on to how to proper handle, store, and of course handle the waste and manage it from the chemicals that you have used. Alright, let's start off with basic. Well, just to jog off your memory. Uh, every chemicals have a pH. So if you don't know what a pH is, don't ask me. Go and Google it up. So pH means it would determine the activity. So it could be from either 1 up until 14. So it could be either acid or alkaline or neutral if it's around pH 7. So chemicals comes with certain hazards. So there are two types of hazards for chemicals: physical and health hazards. So there are 5 physical hazards such as oxidizer over here by the signage, flammable, explosive or explosion, corrosion, corrosive to metal, and of course high pressure system. Okay, usually more or less related to gas. For the health hazard, it is by these 4 signs, which is, well, as you can see over here, this is for the poison or toxicity. The irritant, something that is causing harmful damage to the health, and of course corrosive, another corrosive over here. So in terms of the signage, as you can see, there are some of them you have seen earlier on, okay, but in total there are only 9 chemical hazard signage, and this 9 signage is synchronized all over the world. So previously, prior to 2013, if you have seen some of these signs with background of different color, such as I've seen some with yellow, some with red, so they are the old signage. The new signage starting from 2013 has to have a white background, and the signs is basically in black color enclosed by a diamond red. So all over the world, this is the chemical hazard signage, and they are for explosive, for flammable, for oxidizing or oxidizer, gas under pressure, corrosive, acute toxicity, health hazard, serious health hazard, and hazardous to the environment. Now let's have a look at each and every one of the signage, how to decode it. So the first one is the health hazard. You can see a human over here with something glowing again on the chest. So it means that probably the chemical, okay, is carcinogenic, could cause cancer. It could be mutagenic. It could cause reproductive toxicity or respiratory sensitizer, and probably it could also be toxic to certain targeted organs and aspiration. The second signage, which is the flame for flammables and also for pyrophorics, basically it has something to do that with heat or basically ignited, whereupon it reacts with something. So sometimes it could also be self-heating. It could also emits a flammable gas, and sometimes could be self-reactive, like I was saying earlier on, and it could also include organic peroxides. The third one, the most common signage that we will see, is the exclamation mark, which is a sign for irritant to the skin and the eye. It could also cause skin sensitizer. It could be harmful if it causes acute toxicity, and sometimes it could also have a narcotic effect, and sometimes could be irritant to certain respiratory tract to some people, and of course hazardous to the ozone layer. The fourth sign is the gas cylinder, which means that there are gases under pressure. Probably you don't see this often unless you are dealing with gas or doing a lot of GC or HPLC by yourself. The next one is for corrosion. You can see that these are test tubes, okay, on the hands and also on some surfaces and whatnot. So it could cause skin corrosion or burns, could cause eye damage, and to certain metals it could also be corrosive. The next one is the exploding bomb, okay, two denotes or two signs for explosive or certain self-reactive and organic peroxides as well. The next one is flame over circle, which means that it stands for oxidizer. Probably a lot of people would be confused by the oxidizer. Oxidizer is not flammable product, so they are different. Okay, these two signage are different. Don't get confused with them. Okay, don't basically confuse them. So oxidizer means that, okay, usually you have to make sure that it doesn't come in contact or you don't store it together with a flammable, because when the reaction occurs, okay, you could cause an explosion. The next one we have an environment. Okay, you could see some fish over here, probably kind of like a river, and also some tree. So it means that it could basically cause damage to the aquatic system, and of course sometimes cause toxicity to the aquatic life. And the last one, okay, which is, well, by the skull and crossbones itself, we will know that it is actually not a good sign. So it means that it could cause certain acute toxicity, could be poisonous, could be fatal, or toxic. Alright, now all those signage, probably you have seen some of them. Probably you don't realize it or notice it. So they are all basically a part of something that is important, and all those information could also be obtained from the safety data sheet or the SDS. So when you buy chemical, I'm sure most of you here will do some lab work. Okay? Probably some of you are going to do bioinformatics. So, but never mind. Okay? In some cases, okay, if you buy chemicals, you have to know that all chemicals have SDS. There is no exception. All over the world, SDS is mandatory. So, SDS, the criteria, it should be easily accessible, either in hard copy or soft copy. So if your supplier doesn't give you in hard copy, you can ask them for soft copy because it is compulsory for them to supply it to you. So the SDS has to be updated to the recent 5 years. So if you were to compare SDS from one brand to another for the same chemical, sometimes you may see some different information. So go and have a look, check it, okay? Because if it's not updated, then some of the information are missing or not updated. So the importance of SDS, okay, is that all SDS from 2013 onwards should have these 16 sections. If it doesn't have these 16 sections, then basically you need to be very wary of the brand that you buy from. We actually at CMU, we have screened some of the brands that doesn't comply with the SDS, and we actually have blacklisted them. So SDS should have all these 16 sections, and among them some of them are important. Okay, you can just go through some of these sections, but okay, from section 1 up until section 8, go through it when you receive the chemical, because number 1 is for the identification of the hazardous chemical, the name, the trade name, the supplier information and whatnot. Second is the hazard identification. Okay, it will tell you on the signage and explain in detail what harm, okay, will it cause. The third one is the composition of the ingredient of the chemicals, what mixture, the percentage, and whatnot. The fourth one is the first aid measure, just in case if anything happens. Number 5, in case of fire. Number 6, in case of accidental release measure, such as spill or splashes. 7, important, for you to handle later on, and also to store it if you are not going to use it immediately upon receiving. And the last one, not say the last one, but number 8, okay, the ones that I told you to look at when you got it, is the exposure control and personal protection. It would sometimes tell you on which proper PPE to use, face mask, okay, what type of mask and whatnot. Alright, now, like I said, okay, recent SDS have to have these 16 headings, and this is actually compulsory, even by the OSH from Malaysia, as you can see. So, a safety data sheet again must be prepared by a competent person, and you can just read on through it. Not just any person can prepare it, so they have to go through some examinations as well, and they have to be certified, and then only can they prepare the safety data sheet or update them when it requires to. So what should be done when you receive SDS? First and foremost, make sure that there are the 16 headings over here. So some of the headings may not contain some information, fine, it's fine, but make sure that it has to be there, all the 16 sections in the SS. It may say that not available or no information available and whatnot, it's fine. But as long as there are 16 sections, then it is the correct way or the correct content of the SDS. Check that it is in English, and of course it's clear and concise. In Malaysia, we actually require the supplier to supply in both English and BM. But of course some supplier couldn't have it in BM, so well, in Malaysia they are trying to improve on that. Make sure, okay, that okay, it is dated, and any revision date and details of the revisions are also provided, and you can read through all about it. Okay, so make sure that when you receive the SDS, whether it's in the hard copy or the soft copy, make sure that first and foremost it has the 16 headings and it has all the information needed. Alright, so I'm just going to give you a rough example of SDS for those of you in case you haven't seen one or haven't come across one or don't know how to read one. Okay, so this is from my lab, from Biorad, the brand. The identifier, the name of the product or the chemical is 30% acrylamide B solution at a ratio of 39:1. So it has the trade name of the chemical plus some other information, especially the supplier information. This is by the Bio-Rad from US, and of course information of the department, and of course emergency telephone number. Second one, it would tell you on the signage, the hazard identification. So now when you see these two, usually when I ask in courses which one is the most hazardous, people would always answer this one because this is hazardous to health. But you also need to know how to read the SAS in terms of on section 2. So usually the hazard signs are lined up according to the one that cause the most hazards, or basically immediate hazard. So in case over here, the first one is actually the irritant, even though probably most of you, like I said in my course, previous courses, people say that this one is the most hazardous as compared to this. But in this case, in the SAS, it says that irritant is the first in line. Why? Look at classification of the substance of mixture. It says that again, it is harmful if swallowed, which means that it is irritant. Harmful in contact with skin, causes skin irritation, serious eye irritation, and whatnot, as you can see over here. The one that is involving this sign is over here. May cause genetic defects and may cause cancer quite towards the end. So that means that again, doesn't mean that this is not important, but again, this again would cause more damage or more hazard to the handler. Alright, now let's talk about routes of entry of these chemicals. So whether by, hopefully not by on purpose, okay, so usually accidental or accidents do occur, okay, so these are the routes of entry that is quite common. So the three common route of entry would be the eyes, the skin, and also by inhalation, because we all have eyes, we all have skin, which is the largest surface of our body, and we all inhale, okay, we all breathe. So ingestion probably not that much unless if you were to swallow it by mistake. Absorption usually by skin, and of course injection rarely happening, but happen nonetheless. So let's have a look at some of the examples of what happened and what needs to be done, okay, if you got any of the chemical on any one of this entry. So if it comes in contact, okay, with your eye, make sure that you hold the eye open and you flush it, okay, with water for about 15 minutes to remove as much as possible of the chemicals from the water, from your eye. When I say flush it with water, don't use tap water. In Malaysia, our tap water contains chlorine, which would cause more harm to you. If your lab have the eye wash station, use it. If not, then use probably distilled water or ultra pure water. That would be much better. In any case, take your friend or you yourself, if it is you, go to the doctor, take along the SAS and also the label or the label of the product, because, well, doctors, okay, would know, okay, what to do, okay, based on the information from the SAS. So as a preventive measure, always wear goggles or face shield to prevent injury, especially when you know that probably, okay, especially if you were to read in the SAS and you saw that, okay, it causes eye irritation. The second one is if it comes in contact with your skin. So if it is on the skin, when basically you got splashes directly on skin, rinse the area with plenty of water for at least 15 minutes. And it would also be better, okay, for you to use the station as well. If the chemical comes in contact with the clothing or contaminated, so the clothing needs to be removed. Usually if you wear a lab coat, then you need to remove the lab coat. But if it penetrates to your clothes, then sorry to say, you need to remove the clothes as well. You have to make sure that it doesn't come in contact with your skin. That is the function of removing the clothes. So in any case, if irritation persists, then of course, by all means, go and see a doctor. Again, take the SAS or the label with you. So as a safety measure, always wear gloves, boots, or close-covered shoes, not from the cloth material but something rubbery. And of course, face protection. Wear the proper face mask. So there are lots of face masks involved. I will tell you in a while in the next slide. And sometimes in certain cases, if your lab has it, wear the apron. Not the apron that you use to cook in the kitchen. These are different apron. The apron is basically, some of it are chemical resistant. Alright, the last route of entry that I'm going to discuss is actually on inhalation. So sometimes inhalation, you could basically smell a lot of them actually you don't smell anything, and then suddenly, well, either you or some people just fall down, unconscious. So if there is such a case, remove the victim from the area, and at the same time make sure that you avoid becoming a victim yourself. So if the victim is breathing, then make them comfortable, and if it's not breathing, then, well, someone could perform a CPR or cardiopulmonary resuscitation. But well, perform CPR only if you have been trained and you know how to properly utilize the method. Because if you apply too much pressure, then you could damage or break the rib. Not enough pressure, then you're wasting your time, and of course could endanger the victim. In any case, it is always a good idea to seek medical assistance if the patient is not well. Again, take the SAS or the label with you. For this case, if you know that it is volatile, or in the SAS it says that probably it could cause certain damage and whatnot, okay, wear proper breathing apparatus. Not just normal face mask, there are lots of types of masks. For certain type of chemicals, okay, in number 8, they would suggest which type of mask to be used. N95, R95, which type of respirator and whatnot. There are lots of kinds of them. So you need to be aware of all this. Now, in any case, if any such thing happen, what do you need to do? In case of spill or accidents that occur, you need to make sure in UTM, and especially in FS, you need to notify the lab assistant and of course your supervisor. So for the lab assistant, usually they would have to notify the lab manager, which is in this case Dr. Alina, and of course Dr. Alina will inform the SHE or Safety Health Executive, which is for FS is Encik Daniel from the Department of Chemistry. So we also have ERT or Emergency Response Team that could basically should respond immediately to some accident, especially if there is a big spillage. And for your information, every level of FS building, in TO2 especially, we have a spill kit. So where is it? You need to ask your lab staff. Okay, so it's not in every lab, but at every floor we do have a spill kit. Alright, so let's move on to the next video.